Hey everyone, it's Mr. Doan. I am back, and I'm going to be continuing what Mr. Yang started yesterday on rational expressions. Today we're going to be adding and subtracting rational expressions. So let's go ahead and start by labeling before adding and subtracting rational expressions. Now for today we're going to be doing a lot of multiplying, so hopefully you understood yesterday's lesson and had enough practice in class. For adding and subtracting, it's going to be really important that we're able to find common denominators. So when you're working with fractions before, you only had constants. That kind of made it difficult, but it wasn't too bad. In this case, we're going to be working with expressions. So we're going to have variables, we're going to have variables squared, so on and so forth. So there's going to be quite a bit to do. So make sure to leave enough room for all of the steps, because each problem will require a lot of room. Okay, so again, we're going to be adding and subtracting rational expressions. The first example, we'll keep it simple by having common denominators already to begin with. So the instructions are usually going to say perform the operation. In this case, adding or subtracting, and simplify. The reason they add in and simplify is because after adding and subtracting, there will be times where you can actually reduce your fraction further. So let's go ahead and see if that's the case for our first example. In the first one, we have x squared over x minus 3 minus the quantity of x squared plus 5 over x minus 3. Now looking at this problem, we see that immediately they have common denominators. I don't have to actually do any more work for this one. It is subtraction, so we do need to be careful because this subtraction applies to both terms right here. So I'm going to actually rewrite this, taking the numerator there and then subtracting the numerator over there, the whole thing. I like to write it like this because it reminds me that I need to distribute that -1 into both of these terms. So after that, let's go ahead and distribute. I get x squared minus 5 all over x minus 3. At this point, all I can really do is simplify. So x squared minus x squared is going to be 0. And then on top, I am left with -5 over x minus 3. Okay, so there will be examples like that where really all you're doing is adding or subtracting the numerator because the denominators are common. Alright, so that's the end of example 1. If you need to review it, go ahead and pause. But I'm going to go ahead and move on to example 2 now. The instructions are the same, so it's going to be perform the operation and simplify. I'm not going to rewrite it, but do know that we may need to simplify. For this one, we're going to be working with 3x plus 2 all over 8x minus 8 plus negative 4x squared plus 4x plus 5 all over 8 minus 8x. So just by reading that out loud, you can already tell they don't have common denominators. They are, however, very similar. Here we have 8x minus 8. Here we have 8 minus 8x. Our goal is to change this denominator right here, the second one, to look pretty much the same as this one. And there's a quick way to do that. Notice that our constant 8 is opposite of that. And our term with both the coefficient and the variable is also opposite of this one. So what I need to do is actually factor out a -1. I'm going to have 3x plus 2 over here, 8x minus 8, same exact thing. And now I'm going to have plus negative 4x squared plus 4x plus 5. Here I'm going to factor out a -1, and I'm left inside with 8x minus 8. Now by the commutative property of addition, I am allowed to rearrange that. Okay? Now, our denominators are almost the same. I need to do something about this -1. You have two options. You can either change this plus sign to a minus, and that gets rid of this one immediately. Or you can move this -1 and divide it into the 3 terms on top, effectively subtracting them. I'm going to go ahead and change it to subtraction. However, if you know how to change these guys, feel free to do so. So I'm going to cram in as much as I can. 3x plus 2, 8x minus 8. This now becomes subtraction. -4x squared plus 4x plus 5 all over 8x minus 8. So now our -1 is gone. We have a common denominator. We have subtraction. So I'm going to subtract all of these. I'm not going to show the same step as earlier. So I'm going to skip a step. And I see that 3x plus 2 is going to be plus 4x squared minus 4x minus 5. All of that will be over 8x minus 8, the common denominator. On the top now, I need to simplify as much as I can. I have 4x squared minus x plus 2 minus 5, that will be minus 3, all over 8x minus 8. Now I've reached the bottom of the page, and looking at this I can say, oh, I think I'm done. However, you do need to check, is there any more that I can simplify? For this one, there is in fact more simplification you can do. So I'm going to go ahead and turn the page now. And let's go back to this side. So starting off at this point of 4x squared minus x minus 3 over 8x minus 8, I realize that I need to factor out the top expression. I can use guess and check. I can use the box method. Whichever way you prefer to factor, please use it. I'm going to go ahead and use, well, I already factored this one out, so kind of cheating here. But I get 4x plus 3 times x minus 1. So if you were to factor it out using diamond method, the box method, etc., you would be able to get those two terms. Likewise, I need to factor out the bottom. So I'm going to take out the GCF of 8, and I have x minus 1. Lo and behold, because these two are multiplied with each other, I'm allowed to cancel. If there had been a plus sign in between, I would not be able to do that. So be careful when simplifying your terms. In this case, because there's a bunch of multiplication and division, I am allowed to simplify it just by crossing out, with the final answer of 4x plus 3 over 8. Okay? Now there is one thing I do want to mention.
Selena,
we do want to...
Selena, please report to the main office.
Pardon that interruption. So we do want to find the domain for all of these. It's actually a lot easier than for multiplication and division. In this problem, going back to the front page, so sorry, go ahead and flip back. In the original problem, we had two different denominators, 8x minus 8 and 8 minus 8x. We want to see for what values can x be in order to make sure that our denominators are not 0. So let me check to the side right here. 8x minus 8 cannot be 0, so 8x cannot be 8, which means x cannot be 1. If I do this one, it actually comes out the same way. So that would be not equal to 0. 8 is not equal to 8x. X is also not equal to 1. So we know in our domain for sure that x cannot be 1. Looking at the rest of our steps, there really isn't any other different denominator. So really this is the only excluding number. So if we were to write our domain, it would be x not equal to 1, or you would write all real numbers except 1. Okay? Let's go ahead and do that for the top example too. So jumping back just for a moment. Here we see that we have a common denominator, so really there's only one thing affecting it. So x minus 3 cannot be 0, which means x cannot be 3, and that's our domain. Okay, a lot easier today, nothing too difficult. However, that's because it was the first two examples. Here comes number 3. Our third and final example for today involves trinomials. So there's going to be a little more factoring involved here. Our first one is 1 over x squared plus x minus 6. This is going to be minus x over x squared plus 8x plus 15. Alright, so looking at this, I have absolutely nothing that I can do. There's no common denominators, there's nothing that I can really combine at this point. So what I need to do now is factor. There's nothing I can do, so factor it. At the bottom, we're going to get x minus 2, x plus 3, minus x over x plus 3, x plus 5. Again, you would have to factor this on your own normally, so I am kind of skipping a step here. At this point, we notice, hey, they actually do have something in common, this x plus 3. So we don't necessarily have to multiply both terms by more than we need to. However, to make them common denominators at this point, I'm going to have to do multiplication for both of them just to make sure that they have common denominators. In this case, this term is missing this guy. This term is missing this guy. So what I have to do is multiply each one by the part that it's missing. And remember, whatever you multiply to the top, you also have to do to the bottom. Alright, so there's some multiplication involved. I'm going to leave the denominators exactly as they are, so don't bother multiplying them out. Here I have 1 times x plus 5, that's going to be x plus 5, all over x plus 5, x minus 2, x plus 3, minus, over here we have x. We're just going to go ahead and distribute just to cut down the number of steps we have. We have the x here and the x minus 2. I'm going to distribute that x into x and negative 2. So I get x squared minus 2x all over, again, x plus 5, x minus 2, x plus 3. A lot of writing. Okay, so at this point, it's just subtraction. I'm going to have x plus 5 minus x squared plus 2x all over that same denominator, x plus 5, x minus 2, x plus 3. At this point, all I have left to do is to collect like terms. So I'm going to have negative x squared plus 3x plus 5 all over x plus 5, x minus 2, x plus 3. Looking at this right now, I know there's no way I'm going to be able to factor it, so I'm pretty much done at this point. Only thing left to do is to identify our domain. Starting from here, when we factored them out, we got x minus 2, x plus 3, x plus 3, and x plus 5. Which means I know that all of these cannot equal 0. So, we have our 3 exclusions. X can't be positive 2. X can't be positive, or negative 3 actually. And x cannot be negative 5. So, in this case, your domain would be x is not equal to, I'm going to go in order, negative 5, negative 3, 2. Or you would write all real numbers except negative 5, negative 3, 2. Alright, that was a long lesson. I apologize for the video's length. Hopefully it made a lot more sense. And if you have any questions, make sure to write them down in the left-hand column. We will be checking them a lot more thoroughly this time around. So please record any questions that you have regarding this lesson, and the Google form should be up not too long after the video. Alright, see you guys tomorrow.